Hello, everyone. Once again, back with the very new episode of interview preparation. We have already done 4-5 sessions already, in which we have covered Python. Now, once again, we are back with the new series. In this, again, we will start from complete basics, new set of questions that I have taken from internet. We are going to solve that live, and this journey would have more than 200 questions. So stay tuned, keep subscribing, and keep smiling, more important than everything. So let's directly dive into the screen. Okay, so let's get started. I have the questions already written. Okay, you can see the questions and you can try that. Let's try it one by one. Pause the video, okay, and try to solve it. Let's get started. Perfect. Okay, so the first question, as there in front of you, swap the number without using third variable. Now see, this is very important from interview perspective. In Python, you can easily do, okay, swap the number without using third variable. So you can do very easily this in Python. Let's say we have two numbers, A equals to 5 and B we have that is 500. Okay, just so that 200. Let's stay that in your mind that A is 5 and B is 200. Now we want to swap it. Let's zoom in. Yeah. So now we want to swap it. How we are going to swap that without using third variable? In Python, it is very simple. A comma B. You can write it like this: B comma A, and then you can write here A comma B. That's it. So what would happen here? Very simply, your first part, okay, your first part would go inside this, and this B would go inside A. That's it. It is as simple as that. So you can do it very easily. So when I run this, okay, you can see that if I print the value of A once again, it is 200. It is swapped. Okay. And the B value after this is 5. So A comma B would be 200 comma 5. Okay. Now comment it one simple exercise extra other than that. If you are little pro in Python, comment it. Why do we got this tuple creature here? Why do we got this tuple here? Okay. Comment it. I would explain you in the next video. Now the next question, let's try the next question. So this same question we can do in the another way also. I would explain you how you can do that. So imagine we have two numbers because it is a number. So we can do it like this also. X. So let's assume that X and Y are there or A or B are there. So we would first do A equals to A plus B. There are two ways to solve that. A equals to A plus B. So what would happen here? Just give me a second. I would connect my pen. Okay. So like I was explaining you A comma B. So right now let's go back to our step number 1 where we had the same values. Okay. A is 5. So now see how it works. Your A is equals to 5 now. B is equals to 200. Now what you can do is you can do A plus B equals to A. So what I'm doing right now in my A, I'm storing A, that is 5 plus B is 200. So I'm storing in A 205. Now I want to shuffle both the values. Okay, so first I did this. Understand the logic. It's all about coding, is all about logic building. So you need to build this logic. So we got here A equals to 205. Now we will do B equals to, okay, now we want in B there should be 5. Just think for it. In B we want 5. So we can do 205 minus 5. Like that we can do. So right now this 205 is A minus, okay, what is your B right now? Sorry, we can do here 200. So we can do here A minus B. That is your B. So think for it logically. In B, now you got 5. So your first task is done of swapping. We want 5 in B. So I can just do here the next value, that is B is equals to A minus B. Simple as that. Okay, now I got in B, I got the right value, but in A there is not. In A still there is 205. Now in A we want 200. In A we want 200. So we will subtract 5 from it, and that is present in our B. So I can just do here A equals to A minus B. That's it. And if I print A comma B, it would exactly be the same. So in this way, we can solve it in way 1 and way 2. Your interviewer would be happy with any of the way. Okay, but you need to understand this logic also. This is really very cool logic. Perfect. Coming to the next question, pause the video, try it. The second question. Write a program to extract each digit from an integer in a reverse order. Okay, so for example, your program, your number is, let's assume that we are taking a number from a user. Let's take it n equals to int of input, enter any number. Okay, so we are asking a user to enter a number. Now, the moment we got the number, we want to reverse it, write a program to extract each digit from a number in a reverse order. Okay, so we want to extract each digit. So how it should be? So for example, the number is 1, 2, 1, 2, 3, 4. So output should be 4 space 3 space 2 space 1. So like that, we want the output. So how to do that? Now understand the logic here. Very cool logic it is. See, so we have n. Now let's imagine that our n is 1, 2, 3, 4. Now I want this 4. Think for it. Okay, you don't need to memorize it. Think for it. I want 4. How to get 4? Okay, I can just take here n modulus of 10. Just think for it. When you divide any number by 10, what would be the remainder? Let's say if it is 17, you divide by 10, the remainder would be 7. Same way, take a big number, 7,000, or let's take it 1, 2, 3, 4. If I divide this by 10, it would be 1, 2, 3, 0. And if I subtract this 1, 2, 3, 0, you would get 4 as a remainder. So in simple words, if you want the remainder, basically if you want the last digit, okay, you would divide it by 10. So automatically you would get the last digit, whatever it is. So modulus by 10. So I do here modulus by 10. So let's keep it r equals to remainder equals to n modulus 10. Okay, so I did it simple here, n modulus 10. So what I would get here, in r, there 4 would be stored. Now I want the number to be updated. The number was 1, 2, 3, 4. Now I want that the number should be updated here. So now my number should be 1, 2, and 3 now. This 4 should be removed. How to get this 1, 2, 3 now? Okay, you can just in a simple same logic, 1, 2, 3, 4. You can divide now. So 1, 2, 3. Now you want the quotient part. Okay, you want the quotient part here. You don't want the decimal part after it. That would give you this number. So you would divide it simply. Now if I divide this, see, if I take here n, divide by 10, I would get the quotient here. I would write here quotient, that is q. That's it. If I print here remainder, and if I print here, okay, just a second. First, let me print that. And the quotient, if I print, so you would understand it very perfectly that what I'm trying to do here. Enter a number 1, 2, 3, 4. So see, in remainder we got 4 and in quotient we got 1, 2, 3. So you need to understand the logic that we got 4. Same way we can get 3. Same way we can get 2. And same way we can get 1 also. So in this way we will get the reversed order. Now I just need to put that in a while loop, while n. Okay, till the values are there in n. I need to run this. Okay. And now see that if I run 1, 2, 3, 4, okay. I need to break this kernel. See, I am not changing the value of n here. That is the problem. So I need to keep changing the value of n. Then only you would get the right answer. Okay, now if I do that, see, first, okay, understand it. In the same program I have done it. 4, 3, 2, 1. Okay, so I did it very properly. I got all the remainder 4, 3, 2, 1. Now, if I just keep this remainder also, my problem is solved. I want that in reverse digit. I got that. Now I just need to keep that in a variable. That's it. So I can keep that in a variable. Okay, like in this way, you also solve it step by step. Don't start it with a while loop. Solve it first for first digit and then put that in a while loop. So I can keep here just simple a string, empty string here, s equals to empty string. And then instead of printing, I can just do here s equals to s plus remainder I want. So remainder and plus a space in between them, so that we can assume and we can see that very properly. Can only concatenate integers and strings. So yes, we need to convert this into a string. This remainder is an integer. So we need to convert that into a string. Okay. And at last, just let's print the s here also. So if I run this, now see 4, 3, 2, 1, exactly what I said you. Okay. So if you have understood it step by step, first code it and then move to the next question. Very simple. You just need to remember this whenever you want individual digits, modulus and double slash, that is division operator. Okay, floor division, because we don't want the decimal point. Okay, now coming to the next question, write a program that would give you sum of 3 digits. Okay, you want sum of 3 digits. In the same way, like I have, let's imagine I have input 1 2 3. I want the output 1 plus 2 plus 3. Okay, simple as that. You can do it like this. Okay, now let's try to do this again. The same program, the same logic we can use. Just keep that in mind. Give you individual digits like 4 3 2 1. You would get the individual digits here. So now you can add that very simply. Your task is done. See, if you understand the logic, you can solve any problem with the same type of logic. So I can, instead of now concatenating it, I can just simply do here S plus R. Okay, sorry, S, and we would just convert it to a 0. That's it. So let's run it. 1 2 3. Okay, now 1 plus 2 3, 3 plus 3 6. We easily got that. Okay, now we need this print statement. So let's remove this print statement. Okay, we got 6 here. Same way you can try with some other number. Let's say 5 6 7. So like you got here 1 2 3. Same way 5 6 7. You can sum it. 5 plus 6, that is 11, plus 7. You should get 18. Yes, we got 18. So understand, here also I'm doing the same stuff, getting each and every number here using division modulus operator. Okay, even we don't need this sign, then also your program would work in the same way. Okay, we are just taking out each and every number here. Okay, we got it wrong. We need to change the value of n continuously. Okay, so we need this. So again. Yeah. So that's the reason why I'm explaining you, I got in the flow. So what I was explaining you is we need to keep changing the value of n continuously here. So first it was 1 2 3 4. We got 4. Then the n value, this became the n value. Then again we got 3 here. The n value became 1 2. Okay, then we got 2, n value became 1 in this way. And then we sum all these digits. Simple as that. Okay, now coming to the next question. Write a program that would reverse 4 digits. Also check whether that reverse is true. Now see, already we have reversed it. Now we just need to check if the reverse is equals to the old value. Okay, so that is also very simple. We will take the same program. I was just explaining you, one logic can solve a lot of problems. So every time understand the logic, don't memorize it. So same way, if I copy paste this, still if this logic is not clear, comment that. I would explain you in more better way. Okay, but I hope all of you are able to understand this. Now I want to check if the reverse is equals to the original digit. So I need to store that reverse now. How to store the reverse? In the same way, but this time we don't need the space. So S plus string of R. So this would print the reverse of the digit first. Yes, see, 4 2 3 1, 4 3 2 1, 1 2 3 4 reverse we have printed. Now I want to check if that reverse is same as the original number. So I would just write here, if S equals to original n. We need to store the original value also, original value of n. So I'm going to store here if S is equals to the original value. Okay, but your original would be string. So let's convert both of them into a string so that there is no confusion of the data type. So let's print yes here if they are same, and else print no. That's it. We are simply doing it. So 1 2 3 4 reverse is not same, 4 2 3 1. So it's a no. If I type here 1 2 2 1, so reverse is also 1 2 2 1. So yes, it is right. So in this way, same logic, we have solved already 3 questions. Okay, now write a program to find the Euclidean distance between 2 coordinates. Now this is a very cool mathematical question. If you know about Euclidean distance, very good. If you don't know about it, in short, I would explain you that. So what is Euclidean distance? So this is a graph paper. You know that in your childhood days, you used to have a green graph paper. And in that, you used to mark 2 coordinates. This is your x1. This is your y1. Okay, let's assume it like this. We have some coordinate system that is, let's write it like this: 5, 10, 12, 15, 20, 25. Then here we have 1, 2, 3, 4, 5 like this. Let's take 2 points here, 1 here and 1 here. We want to find the distance between them. So we will first write the coordinates of this point, that is 10, 1. So this is 10 and this is 1. So 10, 1, this is the coordinates here. And for this, it is 20, 4. Now, if you want to find the distance between them, and that is Euclidean distance, how you find out? You find out the distance between the x coordinates, that is 20 minus 10. You find the distance between y coordinates, that is 4 minus 1. This 4 minus 1. You take the square of both of them. Okay, simple as that, because distance cannot be negative. You put under root and you add a plus sign in between that. That's simple, the formula of Euclidean distance. Now, same formula we will code line by line into our program. Okay, so let's try to do that. Same coordinates we will take 10, 1, 20, 4. 10, 1 and 20, 4. So let's do that. Your x1 equals to, let's keep it as x. Let's say, let's keep the coordinates as x1, y1. So x equals to, let's put that x1 comma y1, and y equals to x2 comma y2. And what are that coordinates? Let's write that also. Already we will write it. X1 equals to, what was our coordinates? You remember from the example which I showed you, 10 comma 1, and this was 40. Yes, what it was, 10 comma 1 and 20 comma 4. So 20, 20 comma 4. So let's put the value. X1 value here is 10. Okay, y1 value here is equals to 1. Then x2 value is equals to 20, and y2 value is equals to 4. Simply we have returned the 4 values. Now we will find the Euclidean distance. Okay, ED I would write it. That is, to take this, now first we need to find the difference, that is x2 minus x1. Okay, then plus y2 minus y1. Now we want square of this, so we would put that into the bracket. Already I run that. Okay, so we want to put that into the brackets, and we will take a square. How to take a square? You know that, star star 2, and here also star star 2. Okay, now we need to put everything into a square root. Okay, so we can just use here the function to get the square root of it. If we just do here print ed of, how to take a square root, ed of star star 1 divided by 2. Okay, so this is how we can take the square root also. So basically how it is written, see, square root can also be 4, square root can be written 1 by 2 like this. So that's what I have written here. Let's try to find out. Okay, so you can check that. See, you can write here 4 star star 1 divided by 2. You would get the square root of 4. Same way, square root of 16, you would get, you need to put this in a bracket. Yeah, square root of, see, that's the reason I have put that into a bracket. So you need to put that in a bracket, then only you would get the square root properly. So 16 square root is 4. Okay, 25 square root is 5. You can check all that stuff. You would get the same stuff. So if I run this now, x1 is not defined. So it says x1 is not defined. Yeah, so this we need to just comment it out. Yeah, so now we got here 10.44. Okay, you can check this also. There is a formula you can use, import maths. This is inbuilt in your Python. You can use that and check it. You can use math.distance. Okay, math.distance, and inside that you need to give this x1 y1 pair. So for that, how you need to give it, I would explain you. X equals to x1 comma y1, and y equals to x2 comma y2. If you give this value and you just provide it x comma y, that's it, you would get exactly the same answer. So Euclidean distance can be found using this formula also. In that you need to give it in this format, x1 y1 x2 y2, or you can code it completely from scratch also if you understand the basics. Okay, now let's move to the next point. Write a program that would tell whether a given number is divisible by 6 and 3. Both the things are mentioned. So this is very simple. You can do it. If n modulus 3 equals 0 and n modulus 6 equals 0. Okay, so this is your first bracket. This is, every time put that in bracket so you never get confused. N is used to check two conditions. Okay, 3 divisible and 6 divisible. If it is both divisible, print yes. You can write your print statement. I'm just making it simple. Okay, and else print not divisible. Okay, and we can keep n values. We can check that. Let's say 12 is divisible by 3 and 6 both. So let's see that. Yes, it is divisible. If I make it 9, which is not divisible by 6, so it would say not divisible. Okay, I hope the speed and everything is super clear. Now coming to the next question here. Write a program that would take 3 digits from a user and add the square of each digit. Now again, this is exactly what I have already taught you. You need to take 3 digits from user and add the square of each digit. square of each digit. See how simple it would be. So we have already written this program where we add the digits. Okay, you remember 1, 2, 3 digits addition, this program. I would take that. Okay, same logic. Instead of doing just R, I would just take square of it. So how to take square? Like this, we can take the square. That's it. So if I enter here two numbers, let's say 1 and 2, square of 1 is 1, square of 2 is 4. So 1 plus 4, that is 5. You can check like that. You can enter any number also. 345, let's say. Okay, and if we take the square of that, 3 square is 9. 9 plus 4 square is 16. 16 plus 9, that is 24. 24 plus 5, 25 plus 5, that is 50. So in this way, you can add the values. Now, write a program to check whether a number is Armstrong or not. Now, what do you mean by a Armstrong number? So first of all, you need to understand what is a Armstrong number. If you know about that, that's very good. Okay, if not, I have written the notes. I would explain you from that. Armstrong number is basically you just raise every digit. So for example, you have 1, 2, 3. You would take here now. So basically, you would take here cube of everything. So if you have a number 1, 2, 3, you would take cube of 1, cube of 2, cube of 3. If the sum of all these cubes is equals to 1, 2, 3, it is a Armstrong number. So let's try to code it. Again, the same stuff, the same program. In this, we were taking square. Now we will take cube. So we would get the S value here. So let's try to put a number 1, 2, 3. Now this 1, 2, 3, the sum of cube of every element is 36 only. So 1, 2, 3 is not an Armstrong number. So we would just check it now. If S equals to the original number, we want the original number to be stored here. So original number equals to N. So if S is equals to original number, in that case, we will print that it is an Armstrong number. Else we will print, okay, not an Armstrong number. Let's run this. We will check 1, 2, 3. Yes, it is not an Armstrong number. But yes, 371 is an Armstrong number. Let's check that. 371. Yes, 371 is an Armstrong number. 3 square is 9. Okay, 7 square is 49 and plus 1. So that is equals to, we want cube here. So 3 cube is 27. 3 cube is 27 plus, okay, 7 cube is 49 into 7, whatever it is, plus 1, that is 371. Okay, that is why it is an Armstrong number. Okay, so now the last question, write a program that would take user input. So if it is 4 digits, it can be 3 digits, 2 digits, whatever it is, and check whether the number is Narcissist. What do you mean by Narcissist number? So if a number that the sum of its own digit raised to the power of number of digits. So if you have, let's say 1, 2, 3, there are 3 digits in this. So you would raise everything to the power of 3. If you have 4 digits, 1, 2, 3, 4, you would raise every digit to the power of 4. Okay. And after that, you would sum all the digits. That should be equal. A number is a number that sum of its own digit raised to the power of the number of digits. It should be same. Okay. So let's try it out. Once again, we will use the same code. See, the same code is used for at least 5 problems. So you need to understand the logic. The main reason why I kept this is so that you understand the importance of logic building. So again, we got every number, but now this time we will not keep it fixed. We will calculate here the length of original, okay, whatever the number is, and that we will multiply here. That's it. Everything else would remain same. Instead of writing a Armstrong number, I would write whether it is a Narcissist number or not. Let's run this. If we do 1, 2, 3, okay, object int has no attribute length. Okay, so we need to convert this into string because it does not take here. It does not take integers here. Okay, perfect. Let's run it. 1, 2, 3. Okay, it's not a Narcissist number. But yes, if we do 1, 2, 3, 4, it is a Narcissist number. And still we are not able to get that. Okay. Sorry. Yeah. 1, 2, 3, 4 is not a Narcissist number. Let's search on internet which one is the Narcissist number. And let's try to find out that. So 153, it's called as a Narcissist number. Okay, let's try to run this, whether we get the same stuff or not. Yes, we got that. So our program is working fine. The same logic, everything. That's it for today. Now stay connected. In this second thing we are going to work on is input and output type of problems. So that's it for today. Keep smiling, keep smiling, keep smiling, everyone. Bye bye. Take care.